That's right, Zaya. And the reason being, where CO2 we breathe in and out at each breath we take, and of course we take about 17 per minute. Bicarb we don't. Bicarb we filter in the kidney, we store in the urine and the bladder, so bicarb doesn't change with each breath you take. Is that okay, Zaya? So when bicarb changes, well, it's not changing your CO2 in any ways, because CO2 is immediately ventilated in or out. Whereas when CO2 changes and it causes a change in bicarb, the change in bicarb is there to stay. It's not a gas. So we're doing good there. So what would be the first thing you look at out of the three numbers? The pH, and number one here, I see pH less than 7.4, more than 7.4, sorry. So I'm thinking alkalosis. Or essentially, there's low protons. I know it's directly proportional to PCO2, inversely related to bicarb. So either there is decreased PCO2 or and increased bicarb. That's the only way I can explain the alkalosis. Everyone is okay with this? So number two, well, who of bicarb or CO2 seems to correlate with a high pH? PCO2, it's actually greater than 40. It's not decreased. And bicarb, it's greater than 24. It's increased. So number two, I'm going to say I have a presumptive metabolic alkalosis. Everyone is okay with the presumptive metabolic alkalosis? Give me a reason to have a presumptive metabolic alkalosis. What could it be? That's the part that's easiest of acid base. What could be reasons to have metabolic alkalosis? Too much or too little aldosterone? So aldosterone promotes metabolic alkalosis. So Maria, too much. Is that okay? So increased aldosterone. Why not? Vomiting. Why not? I'm losing protons. Maybe taking diuretics like thiazides. Loops. Is that okay? Maybe having disorders like Bartter syndrome, Gilman syndrome. These mimic literally loops or thiazide. Whatever you want with metabolic alkalosis. The idea is, whatever that causes, now I need to argue the CO2. So number three is argue the CO2 at 50. So to do this, what you're going to remember is what should the CO2 value be if there was a full compensation. Anyone remembers? Anyone can tell me? In metabolic alkalosis, PCO2 will increase to compensate. And it'll increase by how much? Not sure? Let's go check it out. So I have a metabolic alkalosis. pH is increased secondary to increased bicarb. PCO2 must increase by 0.7 millimeters of mercury for each 1 milliequivalent per liter increase in bicarb. Is that okay? So that's what we need to calculate. And let's try that. So what is the value? Increase PCO2 by how much? I'm listening. What's your rule here? Your turn. SPF, you were going to answer. Increase PCO2 by 0.7 millimeters of mercury for each 1 milliequivalent per liter increase in bicarb. So Zahir, that's right. Here bicarb went from 24 to 38. So plus 14 milliequivalent per liter increase in bicarb. Hence, the increased PCO2 is by 0.7 times 14, which is plus 9.8 millimeters of mercury. Allah, you see what I meant? We're not going to argue a little hair like this. So we're going to say 240 plus 9.8, 49.8 millimeters of mercury. Here at 50, assume full compensation. And of course, that's why your best answer, it wasn't B, it was A. Partially compensated would have been between 40 and 50. Like if it had said 45. Metabolic alkalosis and respiratory acidosis, it would have required PCO2 greater than 50. Overcompensation doesn't exist, we said. And combined alkalosis, it would have needed a PCO2 less than 40. And now, if you can do this, you can do all of them. So I hope you'll be set between the notes, between what you've done at school, trying a few questions. If you apply these little rules, you should be able to literally argue any of these problems. Is that okay? Just by looking at CO2, bicarb, and of course your pH. Do notice how pH never goes back to normal, even with our maximum compensation we managed to do. It can approximate normal, but it never makes it back to 7.42 like it should. All right. I'm gonna leave these basics of acid-base and then bring you to still acid-base in a way, but with electrolyte disturbances, and to bring on stories maybe that bring an ion gap. Why not? So shall we try another question? Or do you have any right now with using numbers?